Hello, geometry. This is 1.5, measuring and constructing angles. So an angle is telling us how wide or how close two points are specifically. This right here, this shape that we've had here, this is what we call a protractor. It's not an amateur tractor, it's a protractor. Okay, so this is a protractor. It's used to measure angles. So quick review with this. Here's your zero line. This point right here, that is referred to as the vertex of the angle. Okay, so that's the points. Now we have lots of different angles here. We have small angles, like this one right here, and we have big angles, if we look at this one right here. So when they say find the degree, measure each of the following as an acute, right, or obtuse. Remember that an acute angle is between 0 degrees and 90 degrees. So an acute angle is between 0 degrees and 90 degrees. A right angle is 90 degrees. A right angle is 90 degrees. Obtuse is between 90 degrees and 180 degrees. We'll review that here in a little bit. Okay, but acute, right, and obtuse. The third one we have are straight, or the fourth one, straight angles. Straight angles equal 180 degrees. Okay? So when they say the angle AOB, how these are listed is this is a side, this is the vertex, and this is another side. So it goes side, vertex, side. So you find the measure of angle, you find point A. These are points. These are 3 points here. So here's A. Then we go to O. It's just like a map. It's a direction. So you go to O, and then you go to B. So the measure of angle AOB would be this measure here. So you notice I'm starting here. Here's 0. And then I'm going to go this direction, and it looks to be probably 35. So we'd say that is 35 degrees. Okay? AOC. So here's A. Here's O. We go to C. So this is talking about this angle here. So imagine this ray, OB, is not there. AOC, that'd be 65 degrees. Okay, I'm getting it from right here. I'm not using the big numbers. You see how the big numbers are counting down when I go this direction. I'm not going to use that. The outside numbers in this case would be used if I start on this left side. If I start on the right side, I'm going to be using the inside numbers because that's where 0 is. BOC. Okay, B to O to C. Now you may say, oh, it stops at 65 at 65, but remember, I'm starting at 35. So if I want BOC, I have to take AOC, 65 minus the 35. That gives me 30 degrees. That'd be 30 degrees from here to here, because that's, remember, that's 35, 45, 55, 65. So 10, 20, 30. So this would equal, I'm going to add something here, measure of angle AOB minus the measure of angle, AOC minus the measure of angle AOB. So the larger one minus the smaller one. Larger one minus the smaller one. Okay, angle BOE. Here's B, here's O, here's E. So again, I have to go back to my main one. I need the measure of angle AOE minus the measure of angle AOB. So AOE is when it starts at 0. So this first one, this larger one, must start at 0 degrees. So AOE, okay, again, I'm using the inside numbers. Don't say 35. 35 is if we're starting over here. That would be 145 degrees. Minus AOB. AOB we know to be 35 degrees, so that would be 110 degrees. COE. COE. So I need to start COE. Here's my last point, so I have to start back at here. Measure of angle AOE minus the measure of angle AOC. That's 145. We know that one already. AOC is 65. 65. So that would be 80 degrees. 145 minus 65, 80 degrees. Angle COD. We'll go back and do the acute right obtuse when we're done here. Angle COD, angle COD. COD. Okay. So we can kind of count through there, 10, 20, 30, 45. Probably should be 45 degrees if we're counting it. COD, I need the measure of angle AOD minus the measure of angle AOC. So AOD minus AOC. So AOD would be 110 degrees minus AOC we know to be 65 degrees. So that would be 45 degrees. Measure of angle BOD, two more, BOD. BOD, so that's the measure of angle AOD minus the measure of angle AOB. So AOD we know is 110, AOB is 35, so that would be 75 degrees. And the last one, AOE. AOE. Well, we already know AOE. We've done that up here. AOE is 145. Okay, so going through these, are they acute, right, or obtuse, or straight? 35 degrees, that would be acute. 65, that is an acute angle, such a cute little angle. 30 degrees, acute. 110, that is obtuse. Don't be so obtuse. 80 degrees, less than 90, acute. 45 degrees, less than 90, acute. 75 degrees, less than 90, acute. 145, greater than 90, obtuse. Okay, we'll go, here's some terminology here. Okay, and what we're going to do is we're going to draw a big angle and label some of this stuff in here. Let's call this angle, I'm going to put this point up here, G. Our vertex will be H, and then S right there. So this is an angle. An angle is made up of two rays that have a common endpoint. Okay, two rays that have a common endpoint. So in this case, this angle is made up of ray HG, so there's ray HG, and ray HS. Okay, the vertex is the point the rays have in common. Okay, that's the vertex. So our vertex here is right there. That is referred to as the vertex. The sides of the angles, those are the rays. So that's the HG in this case, and the HS. So this is a side, and this is a side. The interior of the angle, that would be this part right here. Interior. It's the part inside. Exterior would be outside. So the interior angle and the exterior angle. Okay, the interior of the angle is if you connect the 2 points, that's where the interior would be. Okay, the interior would be where those 2 points connect. So the measure of an angle, it's a number that describes how far apart the 2 points on the rays are from each other. Okay? So if it's a small number, these 2 points, G and S, are relatively close to each other. If it's a large number, they're farther away from each other. Acute, right, obtuse, straight, we already talked about those. Congruent angles, these are angles whose measures are the same. Angles whose measures are the same. So if that's 45 degrees, if they're acute, that would have to be 45 degrees. Okay. So this is X, Y, Z. This is A, B, C. We could say angle XYZ is congruent to angle ABC. Now remember some of our discussion that congruent is different than equals. Shapes are congruent. The measure of angle XYZ is going to equal the measure of angle ABC. Okay? Remember, the shapes are congruent. Shapes are congruent. Numbers are equal. So the measure is a number. It's going to be equal. The shape is going to be congruent. An angle bisector. There's that word bisector again. Okay? This is a ray that cuts the measure of a larger angle in half. Okay, a ray that cuts the measure of a larger angle in half. So if I get an angle here, let's say, and here's a ray, another ray. So if this is 30 degrees and this is 30 degrees, this ray, let's call this BC. We could say ray BC bisects angle ABD. Okay, so here we have an angle. It's split it into two 30-degree segments. So ray BC bisects angle ABD. Now there's a common thing of using just the vertex to name a label, which is possible. If we go back up to here, these congruent angles, I can refer to this angle as angle Y. I can refer to this one as angle B. Because here, this is the only angle that has Y as a vertex. So I know which angle I'm talking about. When I come down to this diagram, I can't say what's the measure of angle B. Because there are actually three angles that use B as a vertex. There's ABC, CBD, and ABD. So when you get multiple angles sharing a vertex, you have to use the three letters to name it: a side, a vertex, and a side. Okay, this is a lot of what we've talked about already. The measure of an angle, it's written, there's that M. It equals absolute value of the difference between the real numbers. We talked about that in the first one. Acute, right, obtuse, and straight angles. There's those definitions. Angle addition postulate. Okay, so let's say we have an angle here, and this is 10 degrees, and this is 35 degrees. And let's call this angle, let's go back to GHS. And they just say, find the measure of angle GHS. Well, GHS is the bigger one, so you just have to say, okay, this is going to equal the measure of angle GH, let's put a B there for bluebirds, measure of angle GHB plus the measure of angle BHS, so that is 35 plus 10, which is 45 degrees. Don't overthink it, just add those two together. Or if you know the total and you're looking for one of the smaller ones, you will have to subtract. Okay, so name three different angles in the diagram. Okay, so these are an angle with a ray going through there. So here we have angle EFG. We can have angle GFH. So those are the two smaller ones, EFG and GFH. They're two smaller ones. They would add to the total one, which is EFH. So I always practice. I'm going to do the two smaller ones, angle QRT, angle TRS, and angle QRS. Two smaller ones, angle LMN, angle NMK, LMN, NMK, and then angle LMK. Find the indicated angle measure. Find the measure of angle JKL. So J, I'm going to find it. JKL, that is the big one. That is the big one. So I have to add these two together. If I'm looking for the big, add the two smaller ones. Add the two smaller ones. So 31 plus 85 is going to be 116 degrees. Right? 80 plus 30. 8 plus 3 is 11. Yeah, 1 plus 5 is 6. Okay. Okay, the measure of RSU is 91. They give us that. RSU, you see this is the big one. This is the big one. RSU. Find the measure of angle RST. We want a small one. So if we want a small one, we have to take the big minus the other one, the other small one. So 91 minus 69, 70 to 90 is 20, so that'd be 22 degrees. 22 degrees for the smaller one. Okay, some variables. UWX is a straight angle. Okay, what does that mean? What do we know about straight angles? We know that they equal 180 degrees. Find the measure of UWV. UWV, I'm going to look and see what that is. Okay, that's x plus 20. And XWV. XWV, here is just x. Okay, so geometry is a lot of knowing definitions and knowing what things equal. And if you don't know what something is, you have to look it up. So a straight angle is 180. They have to add to 180. So they, being the x plus 20 plus x, have to add to 180. So now we get to use our awesome algebra skills that your awesome algebra teacher taught you. And we get x equals 70. That makes this 70 degrees. That makes this something's not right. Okay, this would be 2x plus 20 equals 180. That should be 160. So that would be 80. So this would be 80 degrees. I knew something wasn't right. That was 70, and this one would be 90. I was like, 70 and 90 don't add to 180. That's 80, and that's 100. Now they add to 180. Okay, I was checking my work. Okay, find the measure of angle CAD, CAD, and BAD. Okay, we have these terminologies here, and we know that overall the big one is a right angle, so that's 90 degrees. So the big one's right angle, that's 90. So I go x plus 15 plus 5x plus 57, and that's going to equal 90. So x plus 5x is 6x. 15 plus 57 would be 72. That equals 90. So minus the 72, we get 6x equals 18, so x equals 3. So if x equals 3, I'm going to go up, plug it in here. 3 plus 15 is 18 degrees. 3 plus 15. 5 times 3 plus 57, a big one. So 15 plus 57 would be 72 degrees. Okay, so 18 degrees for CAD, 72 degrees for BAD. Ray EG bisects, that means cuts it in half, angle DEF. Find the measure of angle DEG and GEF. Okay, so how this is written is this 92 degrees represents this arc, and this arc, that would be the measure of angle DEF. So the big angle, this is the big one. 92 is the big one. So if it bisects it, we have to cut it in half. 92 divided by 2 would be 46 degrees. So that makes this 46 and this 46. Okay, so both of those would be 46 degrees. 92 divided by 2. Okay, a little bit different setup here. QR bisects PQS. They want the measure of these two angles. Okay, so QR is cutting these two in half. We don't have a total. This is different than number 6 and number 7, where we knew two angles added to 180, two angles added to 90. These two angles equal each other. So the two smaller angles equal each other. Okay, so this is a little bit different setup where you have to set these equal to each other now, which means when I say equal to each other, you have to say, okay, 4x minus 10 equals negative 3x plus 130. I'm going to add the 3x over. 7x minus 10 equals 130 plus the 10. 7x equals 140. So x equals 20. They want the measure of the angle, so now we're going to go back up here, plug them in. 4 times 20 minus 10, that'd be 70 degrees. This one should be 70 as well. Negative 3 times 20 plus 130, that's negative 60 plus 130, that's 70 degrees as well. They should be equal because it's bisecting, that's 2 equal parts. So, okay, that's it for the student journal practice. We'll see you in our next class. Go Bluebirds!